Fine. We looked at semaphores. We saw quite a bit about what they are, how they work, what they mean, and all of that. But what are the problems associated with using a semaphore? See, when we saw the first solution to this critical section problem, which is, I believe, the Peterson solution, it looked like a very effective way, logically speaking, foolproof. But the biggest problem with it was it can only deal with two processes, right? So if the moment you have a third process, Peterson solution is out of the question. You cannot use it. So which is why we came up with mutex, and we also looked at semaphores. So now the thing about semaphores is, logically speaking, it is quite an effective way of handling the critical section problem, of handling clashes between processes. But it is prone to errors, it is prone to human errors from the side of the programmer. So we saw what wait and signal means. So wait is when you are acquiring a resource, so you decrement the number of available resources by 1, and signal is when you are releasing it, so you increment it back by 1, which makes sense. But what if by mistake someone wrote a program like this, where they signal first and then they execute, and then they execute the critical section, and then they call the wait function. See, typically when you need a resource to deal with your critical section, you're going to call the wait function, wait for the resource if it is occupied. Once it is available, you're going to take one instance, hence decrement the number. Then you do whatever you want to do with your critical section. Then you signal its release by incrementing the number by 1 again. That is the traditional, logical, correct way of doing it, right? But it is possible someone gets mixed up and writes a code like this, where you're first signaling and then you do your critical section, then you're waiting. So two things about this. One, it is pointless to wait after you've finished your critical section. You don't need that resource anymore. You're waiting for it here, which makes no sense. Two, when you're signaling initially, you're incrementing the number of resources by 1 without having claimed it. So it's like you're trying to return something which you never borrowed in the first place. So your semaphore value is going to get corrupted, right? Let's say you had 5 printers. You had to take one, make it 4, use the printer, and then when you're returning it, you make it 5 again. Without taking a printer at all, if you're going to increment it, the 5 becomes 6. When you have only 5 printers actually, but your semaphore variable says you have 6. So you're corrupting the variable. So this kind of a mistake is always possible, firstly. Secondly, here wait, critical section, fine. Here instead of signal, by mistake if the wait function gets called, you already have one resource which you're supposed to be returning, but instead you're claiming another instance of the same resource. Again, two problems. One, you're taking a resource which you don't need. Two, someone else might be in need of that resource and you are claiming it instead. So you're depriving another process of what it needs to be executing. So the point I'm trying to drive home here is, it is possible. Another third problem is, suppose a process omits either wait or signal. Again, it is going to be permanently blocked. Let's say you take the resource but you forget to give signal. So you're not returning it at all. Then how is the next process going to ever get a resource? That kind of thing, right? Or if you forget to use the wait function, then you're not taking up a resource at all. How is your process going to be able to do what it wants to do? So the thing with semaphores is, logically it is a good enough solution, but there is always room for this kind of human errors which might be caused by oversight. So is it possible to come up with some slight variation on semaphores which prevents these kind of errors from happening? So is it possible to define and implement semaphores in such a way that inherently they are programmed such that they happen in the sequence wait, critical section, signal, and you cannot end up doing any of this even by mistake? So that's the problem with semaphores, that's the question about semaphores, and that is going to be answered by monitors.